Hey, good day or good evening, guys. What I want to do is review for the midterm by way of actually going through it with you. Okay. Typically, what I do is I'll save a PDF file of the exam, but due to the nature of a lot of these questions, that's not, I believe, going to be the most efficient way to do this. So I kind of feel like the best way is going to be to actually go through the exam, answering the questions, because there's lots of multiple choice, and then, doing any scratch work on the side if necessary. All right, so let's go ahead and get started. So I've got 75 minutes. Hopefully that'll be enough. Okay, so question 1, it says, determine whether the data set is a population or a sample, and then explain your reasoning. It says the number of children for each household in a town. I think that this is a population, okay, and I think it's because of this word right here, the number of children of each household in a town, okay. So I think it's going to be choice A, which says a population because it is a collection of the number of children for all households in the town. These other choices are incorrect. Okay, so I'll go to number 2. Determine whether the data set is a population or a sample. The diastolic blood pressure of 10 patients in a hospital containing 200 patients. Well, this is going to be a sample, guys, because these 10 patients are a subset of the population of 200 patients that comprise this hospital. So I think it's going to be choice B that says a population because it is a subset of all patients in the hospital. And then number 3, same question. The carbon monoxide level of 17 of 98 people who escaped a burning building. I think this one's probably also going to be a sample, okay, because we're not checking the carbon monoxide level of all 98, but only 17. So I think it's a sample. And I'm going to go with choice B, which says the data set is a sample because the collection of 17 people is a subset of the 98 people who escaped a burning building. All right, number 4. Same thing here. The number of guests in each room of a hotel. This one is going to be a population again because of this word right here, each. Okay, so it's going to be choice D. The data set is a population because it is a collection of guests of all rooms in a hotel. All right, number 5. Determine whether the underlying number describes a population parameter or a sample statistic. Explain your reasoning. It says 67 of the 93 passengers aboard an airship survived an explosion. I think that this is going to be a parameter. I think it's going to be choice D. It's the numbers of population parameter because it is a numerical description of all of the passengers that survived. Okay. Yeah. Just make sure you guys read through these carefully. Okay. Number 6, same thing here. You want to determine whether the underlying number is a statistic or a parameter. A sample of employees is selected and it is found that 35% own a vehicle. Well, I think this is a statistic, guys, because it says right here that this number comes from a sample of employees. So the 35% is a statistic. I think it's going to be this last one, statistic, because the value is a numerical measurement describing a characteristic of a sample. Okay, and that characteristic would be the proportion that own a vehicle. Number 7, determine whether the variable is qualitative or quantitative, and explain your reasoning. So, times to complete an obstacle course. Well, you guys remember, most of the time, not always, numerical, things that are numerical tend to be quantitative. Okay, so and the data here is actually a measurement. It's a measurement of time, so we know measurements comprise quantitative data. Okay, so the variable is quantitative because the times are, well, here you go, numerical measurements. And number 8, same thing, determine whether the variable is qualitative or quantitative, and explain your reasoning. Favorite brand of computer. Well, guys, this one is qualitative, okay, because you can't, this would be, this is the most basic type of data. You couldn't really do much with it. Certainly no mathematical operations. So let's see here. Qualitative, because it describes an attribute or a characteristic. Yep. Okay. Now we're talking about like the level of measurement of data. So question number 9, it says the lengths in inches of a sample of a species of fish caught in the waters of a region are as follows. So this is the data. Determine the determine the level of measurement of the data set. So remember, the lowest level is nominal, and then followed by ordinal, and then interval, and then ratio. Okay. I think that this is ratio, guys, because this has an inherent 0. If it were possible to catch a fish that measured 0 inches, that fish essentially wouldn't exist, okay? And then you can also describe one fish as a ratio of another. So if one fish is like 16 inches long and another fish is 32 inches long, you can say that second fish is twice as long as the first fish. So ratio, it says the data can be ordered and differences between the data entries are meaningful, and a 0 entry is an inherent 0. Okay, so that's what I'm going to go with. Number 10 here. The lengths in centimeters of 22 Ford automobiles are listed. Identify the level of measurement of the data set. Here again, I think this is just like that last one. I think this is going to be ratio. Number 11. Bye, Joan. I'm doing. Alright, guys. Yeah, so number 11 here says the list of books that your friend read for school for the past 5 months is shown below, and identify the level of measurement of the data set. Well, these are just book titles, guys. These are not even like ranked in order of popularity or sales or anything like that. So this is going to be the lowest level of measurement, which is nominal. Okay, now we're on number 12. Identify the sampling techniques used and discuss potential sources of bias, if any. Assume the population of interest is the student body at a university. Questioning students as they leave a student union building. A researcher asks 330 students about their drinking habits. Well, usually things like this, guys, this is an example of convenience sampling. Because the students are chosen due to convenience of location. Okay, so there's no real effort being exercised here to try to preserve the integrity of the sampling process. Now, what potential sources of bias are present, if any? Let's see here. Well, here's one. It says, because of the personal nature of the question, students may not answer honestly. Okay, I'm going to go with that one for sure. University students. You'll be careful with this one because the population here is just the student body. Okay, so and then this says the sample only consists of members of the population that are easy to get. These members may not be representative of the population. I think that's a source of bias as well. So I think it's going to be A and C on this one. And number 13 here. The same type of question here. Okay. Identify the sampling technique used. It says peanuts are planted on a 47 acre field. The field is divided into 1 acre subplots. The sample is taken from each subplot to estimate the harvest. I think that this one is going to be stratified. Okay. It's not convenience. It's not simple random sampling. The only other thing that it could be is cluster sampling. But typically with cluster sampling, whichever cluster you pick, every one or everything is sampled in that particular cluster. Yeah, so see, a number of subplots are selected in every peanut plant, and the selected subplots is sampled. So that's not the case in this one. Okay, what sources of bias are present? Let's see. Well, this part B, it says certain subplots may have more or fewer peanut plants than others. Samples from these subplots may bias the overall sample. I think that's a possibility. I think that's the only one that I'm going to go with. Yeah. Okay, number 14. It says, determine if the survey question is biased. If the question is biased, suggest a better wording. And the question is this: why is eating ice cream bad for you? So the question is biased here because you're suggesting that it's bad for you already. Okay, so I think it is biased. Let's see. I think it's going to be D. D says the wording should be, how do you think eating ice cream affects your health? Okay, that would be better. because then you're not implying that it's good for you or that it's bad for you. You're getting a more objective response. Okay, so now we're coming to some numerical problems here. So it says use the given minimum and maximum data entries and the number of classes to find the class width, the lower class limits, and the upper class limits. Well, the class width, guys, comes from the range divided by the number of classes. So the range here is going to be 97 minus 12. There's the range. And we want 7 classes, so I'm going to divide by 7. And we get this number. And if you remember, you always round up. So the class width is going to be 13. Okay. Now the lower class limits, they're going to start at this minimum. Okay. So they're going to start at 12. And then you just keep adding 13. So 12, 25, if I keep adding 13, let's see, what would I have? 38, 51, 64, another 13 would be 77, 90, and 103, okay? And then the upper class limits are going to be, well, the 12, we'll look at this. The 25 is the lower class limit of the second class. So the upper class limit from that first class had to have been 24. Okay? And then you just keep going. Basically, like what you're doing here is, wait a minute, just a second here. I think I might have too many. Yeah, I actually put 8 in there for the lower class limits. Yeah, actually what you're doing here now is, so the next upper class limit would be 38 minus 1, which is 37. Or another way to approach this is once you have that first upper class limit, just start adding 13 to it. 37, 50, 63, 76, 13 more would be 89, and that's 6. I need one more, because see, 90 is the lower class limit for the last class, so 13 more than 89 would take me to 102. Okay, and that should be it. And guys, some of these, well, I guess we could do this one. I was going to say if they're repeated, I may not do them for time's sake, but this one's multiple choice. So here, the maximum's 92, the minimum's 12. That's a range of 80. If you divide 80 by 6, you're going to get this. We're going to round up to 14, so the class widths will be 14, and they're going to start at the minimum. Okay, so the lower class limits are going to start at 12, so that automatically is going to leave me with A or C. The widths are 14, so I would just start adding 14. Well, it can't be this one. It's got to be this next one, because 12 plus 14 is 26, plus another 14 is 40, etc. And then as far as the upper class limits go, if 26 is the lower class limit of the second class, then the upper class limit of the first class is going to be 25. Okay, that leaves me with B and D, and then you just start adding 14 or whatever that class width is. Okay, so it's going to have to be, wait a minute, well, B says the same thing. Yeah, it's got to be this one, because see, the third number here is 53, and over here it's 54. Okay, So just check these carefully, guys. There's got to be a difference of 14 between all of those. Oop. I didn't put in class width right here. It's 14. And now I'll go on. Okay, I'm going to skip this one because this is just like the previous one. Alright, let's look at this pie charts. Okay, this says, use a pie chart to display the data which represent the number of student loan borrowers in millions by balance owed in a recent quarter. Describe any patterns. Okay, so in millions, this category 1 to 10,000 million comprises 16.7%. And so we really just need to look down here and see which pie has wedges that represent these different proportions. Okay, so first thing I would look at is the 50,000 plus. That's going to be your smallest wedge. So it cannot be A or B. It's going to have to be C or D. And then the next smallest wedge, okay, with only 8.6, oh, these aren't even percentages. This is just 8.6. Oh, million, 8.6 million students owe between $25,000 and $50,000. Okay. Well, this is the next biggest wedge, so we just need to look down here. That category is in green, so it's got to be this one right here, guys. Because then after this wedge, the next biggest wedge is this interval or this class, 10,000 to 25,000. And that agrees with what we have up here. 13.2 million students fall into that category, and then the majority of the largest number of students fall into this category right here, up to $10,000. So it's got to be choice D. Oh, well, I didn't answer the second part of the question. It says most student loan balances are less than 25,000. Okay, because it's these two categories here that comprise the most number of students. All right. Now we're going to be looking at the shapes of some histograms. So determine whether the approximate shape of the distribution in the histogram shown is symmetric, uniform, left skewed, right skewed, or none of these. Well, looking at this, guys, it's got a tail that goes to the right. So this is a right skewed distribution. Okay. Yeah. The shape of the distribution is skewed right because the bars have a tail to the right. So it's going to be choice D there. Number 20, very similar problem here. This is a left skewed distribution. It's left skewed because the bars have a tail to the left. Okay, now we're actually going to find some statistics. So what we're doing here, it says the length in words of 7 articles from a particular newspaper are listed below. We want to find the mean, median, and mode of the data if possible. If any of these measures cannot be found, or a measure does not represent the center of the data, explain why. Well, let's do this in the calculator. Well, actually, no, I'm going to do this one in Excel. It's easier for me to type in these numbers. Okay. Let's see. I'm just going to start typing them in right here. 1372, 1,278, 1,274, 1,124, 815. Let's see what else we got. 1,228, 1,153. Okay. And then what you can do here, guys, is, you remember from the lectures, maximize this. You can select this cell and you can say equals, and you can come over here and select the statistical function that you want to use. We want an average. So I'll click this, and then when it opens up this box, you want to select the cells that you want averaged. See how it puts that in there? It's going to find the average of the numbers from this cell M2 all the way down to this cell M8. And then you just hit enter. Okay? So this is the average, 1,177 point. This says round to 1 decimal place. So the mean is 1,177 point. Let's look back here. Got a ton of windows open, as you can see. 1 decimal place, that 10th place is going to have a 7 in it. Okay? And then it says, does the mean represent the center of the data? I think so. Well, hold on a minute. Yeah, it does. Okay. I was thinking about like outliers, but this one would maybe only be the one outlier. It doesn't say anything about that in these choices. And then it says find the median word count. Okay, so if you're doing this in your calculator, it'll give you both the mean and the median. If I'm doing this in Excel, I need to select another cell right here, and I'm going to tell it to have it find the median. Okay, and I'm going to select the same, whoops, group of numbers, hit OK, and the median is 1,228. Okay. Does the median represent the center of the data? Yes, it does. And then finally find the mode. Guys, I don't know that this one has a mode, because I don't think that any of these values are repeated. So I'm going to put there is no mode. And then it says, does the mode represent the center of the data? And I'm just going to click again. But there is no mode. Okay? So that's how you would do one like this. You can use either your calculator or Excel. Alright, so this one says the responses of a sample of 5,326 shoppers who were asked how their purchases are made are shown in the table. Find the mean, the median, and the mode of the data if possible. If any measure cannot be found or does not represent the center of the data, explain why. Oops. Well, here is the table right here, guys. Okay. And look at the data itself. The data itself is just how a purchase was made. So that data is not even numerical. See, this says that 824 purchases were made online, 1,185 purchases were done by a search and then buying online, 2,290 purchases were made as a result of searching and then buying in a store. Okay, so this is not even going to have a mode. The mode cannot be calculated because the data are at the nominal level of measurement. That's exactly right. Okay. Don't let these frequencies throw you off. The frequencies over here, this is not the data, this is just the frequency. The frequency is actually the way in which, how the purchase was made. And then it says, does the mean represent the center of the data? Well, there is no mean, okay? And then find the median. There is no median, okay, because the data, again, is at the nominal level of measurement. And does the median represent the center of the data? Well, the data set does not have a median. And then finally, find the mode. Well, it will actually have a mode. You just look and see, well, which method was the most popular? Well, it was this one, search and buy in store. Okay, so that is actually the mode. And then it says, does the mode represent a typical entry of the data below? And I'm going to put the mode represents a typical entry of the data set. All right, we're making progress. And this, by the way, guys, is exactly how your exam is going to look, or it should look anyway. Number 23 says the pie chart shows the responses of employees working from home due to COVID-19 who were asked about the biggest benefit of working remotely. Find the mean, the median, and the mode of the data if possible. If any measure cannot be found or does not represent the center of the data, explain why. Well, again, this data is really at the nominal measurement, okay? So there is not going to be a mean. And then does the mean represent the center of the data? Well, there is no mean. Find the median. Again, there is no median because this data is at the nominal level of measurement. And then data set does not have a median. But again, it is going to have a mode. It's going to be the mode, or excuse me, the benefit from working at home that was most popular here, which appears to be the fact that there's not a commute when you work at home. Okay, so I'm going to go with no commute. And then does the mode represent a typical entry of the data set? I'm going to say yes. Okay, now this one, the scores and their percent of the final grade for statistics student are given. What is the student's weighted mean score? So here what we're calculating is a weighted mean, okay? So the actual scores themselves, those are like your data values, and then the actual percentages, those are the weights. And this is actually how your score grade is calculated as well. So for this, guys, I'm going to have to use a little paper here. Let's see. Okay. So the formula is actually this. The weighted mean is equal to the sum of each data value times its respective weight divided by the sum of the weights. Okay, if you remember from your notes. So really what we're doing is we're going to multiply each score by the weight, okay? And then we're going to add up all those products. Now you want to make sure that these percentages are converted to decimals. So I could probably just do really all of this in the calculator. So 84 times 0.10 plus 82 times 0.15 plus, so see, I'm finding the sum as I go. Okay, now I know in the notes I made a table, and that's fine, but just, you know, for the sake of this video, and then 95 times that respective weight, which is another 0.15 or 15% plus 100 on the projects times the respective weight, which is 35%, plus finally 87 on the final exam times 25%. We're going to hit enter. We get 91.7 divided by, now what we do is we sum up all these weights. Well, this, lots of times this will sum up to 1, okay? Remember, these are, if you look at these as percentages, then they should sum up to, well, sometimes they sum up to 100%. They don't have to. But I'm looking at these guys, I'm looking at 60 here, that'd be another 30, so 90 and another 10 is 100. So if these were decimals, they would actually sum up to 1. You can do that if you want. And then anything divided by 1 is itself. So we're going to get 91.7. Okay. This has rounded 2 decimal places. Oh, okay, as needed. Okay, well, we don't need to, because anyway, that would be the average. All right, let's look at this one. So the depths in inches at which 10 artifacts are found are listed. Okay, so these are the depths. It says find the range of the data set. Well, to find the range, we just need to find the greatest value and subtract from it the smallest value. Let's see. Well, I think the largest value is 43.8. Looking at this data set. I'm going to subtract from that the smallest value here. Let's see a 24.9. Yeah, 24.9. So it'd be 18.9. And then it says change the 43.8 to 62.4 and then find the range. Well, if the maximum is now 62.4 and you subtract the minimum, which is still 24.9, then you get 37.5. Okay? So that would be the new range. Anyway, it's kind of a weird problem. Okay, let's look at this one. The number of regular season wins for 10 football teams in a given season is given below. Determine the range, the mean, the variance, and standard deviation of the population data set. Well, you can do these in your calculator. The only thing about the calculator, it'll give you, well, it'll tell you what the maximum and minimum is. You have to find the range yourself, but it'll give you the mean, the standard deviation, but it will not give you the variance. Okay, let's just go ahead and plug these in. So let's come over here to Stat, and we're going to hit Enter for Edit. I'm going to put these in List 1, so just type in these numbers, 2, 8. Remember, these represent the number of regular season wins for these 10 different football teams. 15, 4, 11, 6, 14, 10, 3, and 7. Okay, now if I have any other entries here, I'm just going to keep clicking delete until they're all gone. There, they're all gone now. So now I'm going to go to stat. I'm going to go over the test, or no, to calculate rather, and I'm going to select one variable statistics. And I put my data in list 1. So there's a couple ways you can access list 1. One way is just by hitting the second key and then hitting number 1, because there's list 1 right up there. Okay. And then I'm going to go to calculate, hit enter. And so the mean is 8. And then let's see, standard deviation. This is one reason I wanted to show you on the calculator. We have two things here. We have S of X and sigma of X. S refers to the sample standard deviation. Sigma refers to the population standard deviation. Okay. Well, we are talking about a population, so it's going to be 4.2. It says round to the nearest tenth, so 4.2. So make sure you understand that, guys, because if you put the samples, if you treat this as if it were a sample, you're going to miss this one. So it's 4.2. And then to do the variance, you can use the calculator, but what you're going to have to do is recopy this number right here and then square it. Because remember, the standard deviation is the square root of the variance. So if you were to recopy this number and square it, then that would give you the variance. Okay. And then finally, the range is just the maximum minus the minimum. Okay. Now you can use Excel as well. You know, if I were using Excel, I'll go ahead and put these entries in. 2, 8, whoops, 15, whoops, I keep mistyping these. 15, 4, 11, 6, 14, 10, 3, and 7. Okay. So now what I'm going to do is, for this cell, I'm going to just redo it, say equals, and I'll come over here, whoops, we want the standard deviation, but oh no, here it is, standard deviation for a population. You guys see that, the dot P part, and then you can select cells that you want, just click OK, and that's it, 4.24, and that's what we got, wasn't it? Now, I can use another cell over here. I can say, okay, let's let this one equal the variance. So let's see, here's the variance, and there's a dot P, so that means we're talking about population, so you want to make sure you differentiate between the two. So here we go. I'm going to select, so try to select those same cells, click OK, and that's the variance. Okay, actually it comes out to 18, which is kind of interesting. But anyway, that's how you do it. I'm just going to go on. Okay. It says you are applying for a job at 2 companies. Company A offers starting salaries with a mean of $33,000 and a standard deviation of $4,000. And then Company B offers starting salaries with the same mean or average of $33,000 but a standard deviation of $9,000. From which company are you more likely to get an offer of $41,000? Well, think about where $41,000 would be with respect to $33,000. In Company A, if the standard deviation is 4,000, 41,000 would be 2 of those. One standard deviation above the mean would be 33,000 plus 4,000, which is 37,000. Another standard deviation above that would take you to 41,000. Okay, so 41,000 at company A is 2 standard deviations above the mean. And if you guys remember, the further away we get from the mean, the less and less likely those values are. So I think you're more likely to get an offer at company B because the standard deviation here is 9,000. So a salary of 42,000 would be just 1 standard deviation above the mean. Okay? So the data, or these salaries at company B, they're a lot more spread out. With company A, all the salaries are real close together to 33,000. And getting an offer of 41,000 is going to put you 2 standard deviations away from the mean, which is going to be pretty rare. So I think I'm going to go with company B. And it says here, because data values that lie within 1 standard deviation from the mean are not considered unusual. Okay, remember that? Okay. Number 28 says the ogive represents the heights of males in a particular country in the 20 to 29 age group. What height represents the 80th percentile? Let me zoom in here. And how should you interpret this? Okay. Well, these are the percentiles right here. So the 80th percentile is this point right here, and that corresponds to a height of 72 inches, which is 6 feet. So the 80th percentile will represent 72 inches. Now, as far as how we interpret this, this means that 80% of all men in this age group in this country are going to be shorter than 72 inches. Let's see which one says that. Yeah, it's this one, part C. This means that about 80% of males in this country, ages 20 through 29, are shorter than this height. Okay. All right, we don't like too much more. It says the ages of the winners of a cycling tournament are approximately bell-shaped. The mean age is 27.1 years with a standard deviation of 3.2 years. The winner in one recent year was 35 years old. So we want to transform the age to a z-score and interpret the results and then determine whether the age is unusual. Okay. So they're giving us the mean of the distribution, they're giving us the standard deviation, and then they're giving us an actual value that's part of this distribution. So let me get some paper again. So to find the z-score, it's equal to data value minus the mean divided by the standard deviation. Okay. Well, if we plug these in, the mean, well, first of all, data value is 35. So 35 minus the mean, which is 27.1, divided by the standard deviation, which is 3.2. This will give us the z-score. Remember, this is the distance from the mean that particular data value is in standard deviations. All right, so get out of this. 35 minus 27.1, and then divide that by 3.2. All right, so the z-score is about 2 point, let's see how we move around this. Two decimal places. So 2.47. Guys, that's actually pretty rare. That means that age 35, as far as cyclists winning this particular tournament, a 35-year-old cyclist would be almost 2.5 standard deviations above the average. An age of 35 is 2.47 standard deviations above the mean, okay, because the z-score is positive. If it were negative, it would be below the mean. And then determine whether the age is unusual. Yes, okay, it is unusual. It says this value is unusual. A z-score outside of the range from -2 to 2 is unusual, okay? Remember, that just means a score outside in the tails, okay, beyond 2 standard deviations, either above or below the mean, is deemed to be unusual. Okay. Number 30. So this takes us into chapter 3. We're talking about probability and counting principles. So a restaurant offers a $12 dinner special that has 5 choices for an appetizer, 12 choices for an entree, 3 choices for a dessert. So how many different meals are available when you select an appetizer, an entree, and a dessert? So here we can use that multiplication principle. If you've, let's see, yeah, if you're watching this and have already gone over 3.4, you can treat this as like combinations as well. So it's like I have 5 choices for an entree and I'm going to choose 1. So 5 choose 1 times I have 12 choices. I think I said that wrong. The appetizer. Anyway, 12 choices for an entree and I'm going to choose 1. So 12 choose 1 times 3 choose 1. Okay. This would look like the first event can occur 5 ways because there's 5 appetizers. The second event can occur 12 ways, or has 12 outcomes because there's 12 entrees. And then the third event can occur 3 ways because there's 3 outcomes. And then you just multiply these. I think it's going to be 180. Right? So anyway, that's what that would be, 180. Number 31 here. It says a company is conducting a survey to determine how prepared people are for a long-term power outage, natural disaster, or terrorist attack. The frequency distribution on the right here, shows the results. Use the table to answer the following question. What is the probability that the next person surveyed is very prepared? Well, how many individuals that were surveyed are very prepared? Well, 245. So to find this probability, we would take 245 and divide by the total number that were sampled. Okay, and then you would round it to 3 decimal places. Okay, so I'm not going to do all that. You just add up all these numbers, whatever that is, and then divide 245 by that number. And that will give you the probability. All right, and then number 32. This I believe is from section 3.2 on conditional probability. It says 2 cards are selected from a standard deck of 52 playing cards. The first card is not replaced before the second card is selected. Okay, so whatever you draw on that first draw will affect the probability of the card that you get on the second draw, because the first card is not replaced. So this is conditional. The probability of the second event occurring is conditional upon the outcome of the first event. So it says find the probability of selecting a queen and then selecting a 7. So the probability of selecting a queen and then a 7. Let me get my paper here. So the probability of selecting a queen, given that you've already selected a 7, okay? Well, if you've already selected a 7, then that means there's only 51 cards left, okay? And of those 51, there's still 4 queens, okay? Because the card that we selected was a 7, so the 4 queens are still in there. So this should end up being 4 out of 51, okay? Whatever that, well, we can do it real quick. 4 divided by 51. So I think it's set to round to 3 decimal places. This would be 0.078. 3 decimal places. Yeah. Okay. Anyway, that should be it, guys, on these. So your review and test should be very similar to this one. Okay. So take that review as many times as you need to until you feel prepared, and then go ahead and take that midterm exam. All right. Well, I'm going to go ahead and stop the recording. It looks here as though I've spent about 60 minutes, so I spent about close to an hour. Okay. Hopefully you guys will spend less time because I did a lot of talking.